All right. Well, good evening, everyone. Thanks for joining us. It's 5:30. Actually, before I start, silent session, so make sure you have your headphones on. Can everybody hear me okay? Good? Awesome. If it's a little too loud or if you need to adjust the volume, there's a little dial so you can use it to adjust your volume. But thanks for joining us. It's 5:30. It's around this time when we decide between like happy hour or dinner. But you squeezed in a session, which tells us, and you picked this session, which tells us that lifecycle management at scale is a topic that you're interested in. So we appreciate you being here. My name is Farzin Bagheri. I'm a principal technical account manager at AWS. And I'm joined here by my colleagues, so I'll let them introduce themselves real quick.
Hi, I'm Andrew Riley. I'm also a principal TAM at AWS.
Hi everyone, John Mario De Luigi here. I'm part of the ServiceNow family and I cover the ITOM products. Super excited to be here with you all.
Thank you. Folks, they're going to join me later after when it's their turn, but for now you'll have me on the stage. Today, together the three of us will dive deep into lifecycle management at scale. By the end of this session, you'll see that it's very much possible to move away from managing thousands of lifecycle emails, improve your operational practices by 90%, improve your operational efficiency, and reduce your cost of operations significantly by reducing your need to use extended support of some of our managed services. We will get there by first diving deep into what lifecycle events are in the cloud. I'll walk us through what are the common lifecycle events that we manage in AWS. And I'll also walk us through the common challenges that we've learned from some of our largest customers and engaging with them. Andrew later will do a walkthrough of what AWS Health is. We'll dive deeper into that and how it fits into the lifecycle management ecosystem, how it actually is a very critical component in enabling customers to manage lifecycle at scale. Then he will also run through some practical implementation of AWS Health by some of our largest customers, and he will actually share a real customer example that we're pretty excited about. Lastly, John will join us on the stage from ServiceNow, and he will do a demo. He will do a walkthrough of something exciting that they're working on about integrating AWS Health and ServiceNow, and he will finish up with a demo. It's a silent session, so we can't really take questions on the stage. Afterwards, happy to meet with you downstairs, outside of the stage. We actually have the AWS Health product team here that would help answer some of the questions as well. So let's get into it. We're going to use the term lifecycle event a lot today. So let's get on the same page as to what we mean by them. Lifecycle events are scheduled changes that require coordination and are part of our continuous improvement in AWS. Some of the three common types of lifecycle events are routine changes. First, I think that's the one that most of us are familiar with. These are the changes that their life cycles, or the timelines are predictable, are easily predictable. So think of a EKS lifecycle of versions that are deprecating and you need to upgrade to newer versions. The timeline for that is 14 months, so you can easily predict them. Same thing for some of the other services that we have. But another type is the less common type of lifecycle events. This is non-routine changes. Think of hardware retirements that we do. These timelines are not really easily predictable. We can anticipate them easily, but we can't really predict their timelines until we get closer to when we want to cycle out a piece of hardware from our fleets. Lastly, but definitely not least, are the urgent changes. These are the types of changes that we don't get the luxury of plan ahead in advance. Think of security patches that we need to roll out globally, and we need to make sure that they reach all the components that need to be updated very quickly. So we may get maybe a couple of weeks of notice in advance. So now that we've kind of covered what are the common types of lifecycle events, we need to talk about why they're necessary. So through these changes, we are able to improve the performance of our services and keep improving the performance of our services. This is also how we enable new features, and improve the security posture of the infrastructure, which is what we're responsible for on our side, on the AWS side. Lastly, this is how we actually keep the components of the cloud up to date and make sure everything is running on the latest versions, both hardware and software. But you need to know that at any given time, there are thousands of changes happening in the background, but we try our best to make sure these things are happening seamlessly and without the need for customers to take action. But there are always a subset of changes that are going to require customer action. So today's session is going to be focused on those types of changes, the changes that require customer action and coordination. So let's look at one example just to bring it all together. EKS Lifecycle, Amazon EKS Lifecycle starts really with upstream open source. When Kubernetes launched a new version, they support it for about 12 months. EKS then supports that same version for 14 months. So Kubernetes supported for 12 months, EKS supports it for a couple more months, so a total of 14 months. That period is called standard support period for EKS. 6 months prior to reaching that end of standard support, the 14 months, EKS notifies customers through AWS Health. And that 6 months is ideally used by customers to upgrade their clusters and move off of that older version. But for customers that can't upgrade in time, EKS will automatically roll them into what we call extended support. So extended support kicks in at the end of that 14 months for the clusters that remain on that older version. That gives you an extra 12 months on the extended support, but it comes at a cost. So during that, as long as your clusters are running on that extended support, you incur cost. It does give you the flexibility, but it also, over time, the cost of this will add up, especially if you're running at scale. At the end of that extended 12 months, so that now you have a end-to-end 26 months of support. At the end of that 26 month, if you still have clusters that are running on the old version, EKS will automatically upgrade your clusters, basically a force upgrade. But all these seem kind of manageable if you're running, your workloads are running on at a smaller scale. Let's say you're a startup or POC size, you're in that scale. You have a couple of clusters, you may have some RDS instances, a few Lambda functions. It's pretty manageable. You can pull up the console, you can go look at the changes that are coming up. You can maybe even rely on looking at documentation every once in a while. But as you get to the growth stage where you're kind of growing, you have now some critical workloads, you have customers that are relying on your uptime, so it's not as easy to bring workloads down for maintenance. This is where most customers start to feel the challenges of managing lifecycle. Email is no longer as reliable. Looking at the console constantly is not as reliable anymore because you may have multiple teams, global teams. You can't really reach across the office and ask your teammate to make sure to upgrade this cluster or take action. But when you get even bigger, to a larger size, hopefully all your businesses are growing at this pace, and you get to the enterprise level where now you have even more critical workloads. Maybe you're relying on hundreds of different services at AWS. Then each of them will have their own timelines, and things continue to get more complicated. Now, at the largest scale, which some of us, we deal with customers that have reached this scale, you're going to have siloed teams that kind of don't communicate with each other at all. And you may actually acquire another company that comes with their own tech debt, with their own backlog of changes that have kind of been putting off because they have competing priorities. So now you have this large set of backlogs across your organizations because the number of resources has grown, number of teams have grown, the competing priorities have increased, where you have to choose between maybe launching a new feature or meeting your business objectives or managing the life cycle of your changes. So at this stage, it's very critical to get very intentional, to use the tools and technology, in this case, AWS Health, to gain the right level of visibility into what's changing and when, and to bring in the awareness to the right owners and stakeholders at the right time, and accelerate driving action towards kind of shrinking these backlogs. So Andrew will join us on the stage and show us the real implementation of some of the solutions that we have helped customers build around AWS Health. And from there on, John will take over for the demo.
Thank you. Oops. There we go. Hey, thanks everybody. And thanks President for introducing the issue. So this is a specific area I work in a lot. So again, my name's Andrew Riley. I work extensively with customers operating at scale and trying to work through lifecycle events. And in particular, I work with them on solutions using AWS Health to help with that problem. So before we go deep into the solutions, are people generally familiar with AWS Health already? Like show of hands? Okay. Most people have heard of it. The particular thing I want to do first is lay some groundwork about what AWS Health does, and in particular, the features of AWS Health that are specifically designed for lifecycle events, because that's what we're using at scale with customers to put into this work. So to go through it really quickly, what is AWS Health? It's the platform on which all of the AWS services communicate to you about events that might be impacting the performance or availability of your resources on AWS. So if you use EC2, S3, RDS, EKS, the service teams are looking to communicate to you about issues going on with your environment and things you need to know about. So we want to keep you informed. Health does this through different channels. So I think everyone is most familiar with first interacting with Health by receiving emails. But the same information is also provided through the AWS Health dashboard and through programmatic means. So the AWS Health API and Amazon Event Bridge and your default bus in your accounts. And it's these programmatic means that we really use to drive change in your environments. So what kind of information does AWS Health communicate? Health events fall into three primary categories: operational issues, account notifications, and schedule changes. Operational issues, these are unexpected events in your environment or unexpected events in AWS. And we want to communicate to you about single instance failures, could be an EC2 instance or an EBS volume. But these can actually range up to control plane events with the API for that service that you're using. So we want to let you know what's going on, that AWS is addressing it, and help you make determinations about, is this me or is this you? Account notifications, these are general events related to the administration and security of your accounts. So security issues, you might be very interested in actioning them quickly, but there are general events about feature availability for the services you use. For instance, introducing that there's another version of an SDK available for you without necessarily deprecating the original version. But schedule changes is where I want to focus today, because schedule changes are resource specific. So meaning there's a specific resource in your accounts that you're using, like a database, a cluster, some instance. And there's a change coming for it on a specific date, and we want to make you aware of it. Within schedule changes, there's a subset, specific event type called planned lifecycle events that were introduced 2 years ago. Planned lifecycle events are specifically designed for addressing the challenges of making lifecycle event management frictionless at scale. They're directly intended to be used programmatically, and these factor heavily into the solutions that we talk about. So the couple features we want to talk specifically about are These are things that Health built based on direct feedback from you. You wanted a better way to pull health event data into tools that you use. You receive email notifications, but you're looking for a better way to do this than parsing that event message. So we're also providing the information in that event in structured metadata that you can better use to match into the payloads for APIs you're going to call. Every event, we're giving you the, sorry, for each of these events, we have a resource specificity, and we're just giving you these events with the full Amazon resource name, ARN, of the resources involved. So to make it easy to understand which account these live in, which region, what's the specific ID of the resource and the service assigned. Along with resource specificity, we're providing dynamic burn down. So that means for each resource, you receive a status, whether that is pending your action or resolved. And you can understand how much work you've done, how much is left to do within your environment. And you wanted to make these events fit into your planning cycles. So when do your teams normally work? Can they balance their priorities with delivering features to your business with the maintenance work that they need to do to maintain their operations? And along with those timelines, you want to be able to maintain visibility of these events through their entire life cycle. So Farzina mentioned that you're receiving notification in advance from the services you use about when these lifecycle events are happening. But for instance, for extended support, you might have 1, 2, or 3 years of extended support occurring after the change date. And you want to maintain visibility of what the status of those resources in your environment so that you can continue to action them. And to give you a life cycle of a planned lifecycle event, this all starts with setting a date. So, for instance, RDS planned lifecycle events for Aurora. The service team gives you 5 years of standard support from the launch of that service. So we know when the lifecycle event is going to occur into the future. They begin planning to send you a reminder about this 1 year in advance. So they begin working to get the list of resources in your accounts in scope for this change and push them to the health burn down service. The burn down service is tracking whether that resource is pending your action or it's been resolved, and then it pushes updates to your accounts. And this process occurs daily. So when you action a resource, the team generates a new list, pushes it to burn down, you get an updated list for what's been resolved recently, and you can better tell the current state of these resources in your environments. And this continues until the change date. So on the change date, this is when this particular change will begin to affect your environment. So whether that's an operational upgrade that you take, or if it's that extended support is enabled, or it could be a security change. If you remember the RDS certificate rotation that occurred last year, there's different types of events that are not specific to extended support. And they're things that we need you to know about and be able to handle on a regular, ongoing basis. So how do you use planned lifecycle events to improve the processes and experience that you have with these resources? I like to frame this conversation with the AWS Health maturity model. The health team developed the maturity model to represent the different stages that you go through in your journey towards health's vision for a frictionless experience managing lifecycle events at scale. So we all start with manual processes, but we want to build into automations that allow you to automatically ingest this data, to assign responsibility for it, and ultimately work towards making it easier for your teams to action these events in the first place. So let's start at the beginning. So in the reactive stage, you're receiving information from AWS Health through the health dashboard as emails, if you've configured chat channel notifications through Slack or Microsoft Teams. These are human readable notifications. They're good for point-in-time awareness. And when you're in small environments, this is a good way to keep informed. So as these teams send you events, you receive emails. and emails like this one. So this one's telling you about Aurora Postgres 13 end of standard support. So is everybody getting these emails? Yeah. Are you receiving a lot of these emails? Okay. So that is what we're here to talk about. It's moving away from emails as the primary mechanism for managing lifecycle events. This email represents a lot of information, though. And it's what service does this affect? What's the version being deprecated? What's the related change I need to do? What date does this occur on? And in specific, if this is far into the future, how am I tracking when I need to follow up on this? Where can I find the list of affected resources so I can start working through it? So in the small environments that Farzin was mentioning, you might have a small team or even single developers within accounts. And you know all the resources used by your applications. So this is manageable. But as you grow and you have more teams and more resources under their management, you need to start to have processes to track these and reduce the risk of missing one of those emails. Because I think from the nods I saw in the audience, there's a volume, there's a challenge with the volume of the number of mails you're getting, right? And you don't want to be in this position where you've missed a critical change for just the other volume of messages you're getting. So as you grow, more teams, like I said. Now you might be in a model where you have SREs or central teams that are responsible for tracking these events. And while they don't own the resources, they own responsibility for making sure that your teams action them on a regular basis and before the change dates. So they're still receiving these human-readable notifications, but you want to start using a programmatic approach. And this is the first thing that we focused on with our large enterprise customers. The scale of whom are using not just tens or hundreds of accounts, but thousands of accounts, potentially hundreds of thousands of resources, and need scalable mechanisms to approach these. So you're receiving events, and you want to use these with your operational tools, your ITSM tools, risk management tools, but you need to do this through a different channel than email. So I just showed you the email version of a health event, but this is that same event received as an event bridge message. It's in JSON format. The human readable message still appears in this event, but the content of this message and the salient details are pulled out into individual key value pairs that you can use with your tooling. You can use them to form the payload of a message that you're going to send to the APIs of your tools to create events in those to track these resources and manage them at much better scale. So I want to highlight a few things. These events have many common fields between a standard health event and a planned lifecycle event, but the first thing I want you to notice is within scheduled changes, I talked about there being this event type of planned lifecycle events. The first thing you need to do is filter down to just these events, because you're going to be taking these into your operational tooling, and we're not trying to recreate the scale and volume issue you have with email. A lot of people suffer from notification fatigue. The whole point of this is to make things clear to, say, central teams, to have a good visibility of just the list of top-level changes, and individual DevOps engineers to be able to understand their particular responsibilities. And the first thing you're going to do is understand there is a top-level change, in this case for Amazon Aurora Postgres 13 end of standard support. And this is reflected across all the health events you receive, across all the regions and accounts that you use. So you can understand there's one top-level change with potentially many resources associated to it. This event is occurring in the future. It's upcoming. It will apply to your accounts on the start date. So in this case, 28th of February, 2026, extended support will begin on your remaining resources you haven't actioned. So use this as the due date for the change request you're creating. And like I mentioned, resource specificity. So in this case, we're providing you the resource ARNs, also the status, and and the update time. So when we last noticed a change with this, moving from pending to resolved. So, pardon me. We're going to share some links about, we'll share some links at the end about solutions you can use to actually just start calling those APIs, like for common tools, at the end of this session. All right, so using that health event, you've called the API for one of your tools, you've recorded this as a change, and you're looping through that list of resources to create subtasks for that change. So this provides you, one, top-level visibility of the list of changes that are affecting your environment, but that can be a concise list. You maintain per-resource visibility for the status of each and the amount of work that's needed in your environment. So you still have a manual action in this case, though, which is you need to assign those tasks to the different teams in your environment. You have reduced the risk of missing an event, and you've reduced the amount of work you need to report on these in your environment because you're automatically ingesting this information in the tools you use. So you don't have a different dashboard or different tool you have to use to manage these things. But as you're growing again, right, now you're tracking these changes, and as you grow further, it becomes necessary to address that second part that I talked about, which is per resource ownership and accountability. So in the second area, pardon me. In the second area, you want to pull in information, excuse me, you want to pull in information about who owns these resources and who can take action on them, and begin the automatic assignment of those, pardon me, of those change tasks to those teams to allow them to action. So my experience here the last year working with customers is that everyone has different metadata they're pulling in from their own environments. A lot of you will have a change management database that's going to give you a good view of your organization. It might be down to per resource specificity. But even if you don't track things as granularly as individual resources, most often one account will have specific contacts, or you'll have specific contacts for an application. And maybe that ties back to financial ownership, cost centers. You also see many customers put standardized tagging practices in place. So there's usually a wealth of information about a specific resource that you can get just from looking at those tags. And again, we'll have some samples later about pulling in that tag information into these processes. But this is an easy way to identify and link these things to their respective owners. All right, so now you know who's responsible for these resources. You're able to automatically assign them and get the right people, right people or teams, the visibility that you have, but to their specific resources only. So you're reducing the noise that they experience and keeping things focused on just what they need to action. And giving them ample warning in advance allows them to fit these things into their planning normal flow of work. It avoids urgent interrupts and the operational impacts that can occur if they miss these events. And really, this is where we see the resolution rate for customers and employees' solutions just take a hockey stick turn. So they get a better experience working through these events. You see them action these events earlier and faster, and you see a return on investment for the time you put in to implement a solution like this. So I mentioned in our most mature environments, what we're really trying to do is make it easier for those teams to action the events in the first place, action their particular resources. So we see teams building workflows off of these systems. So for instance, you might have standard deployment practices in your environment. You want to automatically bring those in and give teams directions about what they need to do to action that event. You probably all use infrastructure as code to a degree, to a large degree. So you might actually be suggesting a pull request to that team just directly against one of their repositories that immediately lets them understand, here's the change that needs to be made, and start integration testing. We also see teams take steps with GenAI triage So they're not just ingesting these events and assigning them to teams, but they're also deciding the priority in which they need to be actioned based on other criteria within their environments. Like, are these tier 0 applications for you? Do you have other priorities for those teams based on cycles you already know? So all of this is to make it easier for you to action these events you just assigned, and with an aspirational goal of fully automating this process, the governance, excuse me, governance policies happening automatically at the same time. I want to give you a concrete example of what one of our customers that we've worked with has done this year. So the BMW Group, they're headquartered in Munich, Germany. They have 159,000 employees across 30 facilities in 15 different countries. They manage 10,000 AWS accounts. And these support the premium digital services in their connected fleet of automobiles, of 23 million automobiles worldwide. And they share similar goals to you. So they want to maintain visibility of their environment. They want to automate processes. But in their words, the technical lifecycle management team at BMW, they want to distill what gets pushed down to their organization. They want to delegate responsibility for the resources and scope to specific SREs and give them the flexibility with guardrails to do these things on their own timetables. And most importantly, TLM wants to do this by keeping noise as low as possible for as long as possible and avoid over-escalating to these teams and causing kind of churn for them. So this is a complete architecture for health in their environment. It's not just plain lifecycle events. I want to walk you through specific sections demonstrating the ingestion, the automated assignment that we talked about. So it all starts with a process to pull the health API on a daily basis and pull in new events and updates to existing events. They take that data, just like I showed you in the example, feed it into an S3 bucket, and begin to power processes based on that. So they're taking a step with AWS Glue to merge data from their cloud data hub. That's the mapping of the resources to the teams that own them and where they live in their environment. They'll take a process to then put a JIRA issue onto the boards for those teams and link them with an overarching legend. So that's their link from the top level change to the individual actions required by teams. And if you're thinking about let's say the 6-month notice and life cycle here, they're allowing those teams to work through these within that period until they have some guardrails. So they're also using the same data to power BI reporting. So they've provided QuickSight dashboards that have row-level security, meaning that myself as an engineer, I only see the resources in scope for my team, nobody else's. The TLM team also uses that as a fail-safe. So within that period of, say, 6 months, if those teams haven't actioned the items with 4 weeks to go in one of these events, they begin escalating to them through ServiceNow. This process results in a significantly improved experience for their teams. I actually do want to call out here that, again, there's more things on this slide than just plain lifecycle events. They're also interested in those issue category events I talked about earlier. So that means the ongoing things or near real-time events they might be receiving. And they want to avoid delays from the once-a-day polling they were doing for the Health API. So integrating with EventBridge, they get push notifications of these events. And they can use these to drive automated workflows, make their teams aware of operational issues with ServiceNow as well. So BMW wants these flows, routing, to work as seamlessly as possible. And based directly on their feedback and the feedback of similar customers, we've launched AWS Health labels just this past week. So this is available for all customers now, but you can filter health events based on whether they're labeled as actionable, and based on their persona, route them to the right recipients for your organization for operations, security, and billing. So if you were looking at the schema or the example event I sent earlier, right at the bottom, the new metadata already appears on those events. And for plain lifecycle events, those are marked action required and with your operations team as the persona. But I want to get back to what BMW achieves with their architecture. So first, by building plain lifecycle event management into their processes and planning, this architecture enables the BMW team to perform most of their upgrades on time, meaning in the last several months, they've shrunk the portion of their resources on extended support to only 4% of their RDS and 2% of their EKS fleets, resulting in a significant cost savings. They've reduced the operational issues from missed events, so where the developer wasn't aware, they took an upgrade they weren't expecting. And they've improved developer satisfaction with a system that respects their autonomy, but also holds them accountable. And all this while reducing the overhead for the technical lifecycle management team by 90%. So I've shown you a lot. And if you're thinking, this is great, but my team doesn't have the resources or time to implement this right now, I want to ask you to strongly reconsider that. The teams that we work with spend about 2 weeks of a developer's time getting familiar with the pattern that they need to deploy and getting a foundational architecture out there that immediately gives them a benefit. So one, catches the events that didn't necessarily have awareness of. You might know that EKS or RDS cadence is occurring, but those off-cycle events or things that are unique, you capture those as well. And directly, if you're already paying for extended support, this investment pays you back. So if you're thinking you don't have time to make this happen, this is where I'd like to turn the mic over to John to talk about how ServiceNow is working to enable the vision of effortless lifecycle management at scale.
Awesome. Thank you, Andrew. You can take that, actually. I'll use mine. So here we go. We are at the final part of this presentation. You're very likely getting ready to celebrate a little bit more with the upcoming parties and all partner events. But this is going to be, in my opinion, the most important session from a point of view of connecting everything that we said about the great innovations for AWS Health into your existing businesses. So how do we take all the technical parts, innovations that we have seen, and we get them to have a bigger context on how they impact the business? There are a few things that I would like to mention, and I'm going to switch screens right now. First things first, please do acknowledge that we have a safe harbor notice. Today we're going to actually, as a matter of fact, announce a new collaboration with AWS, and this is a new integration. You are the very first customers to learn about this integration. And before we go and see a little bit more about it, who has ever heard of ServiceNow? I want to see a few hands up there. Right. And who is currently actively using ServiceNow? Awesome. Good few of you. Who wants to go to the parties? No, I'm kidding. So ServiceNow is, as a matter of fact, a unique platform because you can think about it as the control tower of your AI and software. As a matter of fact, you can see that we integrate with any cloud, not only AWS, although we know that, especially when this event is your favorite cloud, isn't it? We also integrate with all of your systems because we want to make sure that you know exactly what is your IT estate looking like at any point in time. And we merge all this data with your business level of data, which means how do you then associate each single resource to your business applications, to your business processes. Now, this is just to give a little bit more context on why ServiceNow is relevant, because to Andrew's and Farzin's point, customers are willing now to have huge deployments of AWS and beyond at scale. And we have seen that there are different ways in which you could already, as of today, integrate your AWS Health with ServiceNow and essentially get the value of the platform, which is just one thing. If there's one thing you need to remember out of today's session is the context that ServiceNow gives you, not only about AWS and your deployments, but about every single IT deployment that you currently have. This is just the as-is status. And we've been talking to many customers, such as BMW, that really want to have, they want to capture these lifecycle events at scale so that they can have broader context on top of them, and they can manage them a little bit better with change management and with business context. The use cases are the usual ones. The ones that we have heard from BMW is an example, which means how do you get to establish concrete ownership or even a business cost center that is associated with your impacted resource, or even operational issues. We have cost optimization, or even more simply, I would say cloud governance. Cloud governance is definitely one of the biggest use cases here. Now, these are some of the reasons why customers are already doing these manual integrations with ServiceNow, but this is not only it. As a matter of fact, we are very happy to introduce you to one of the newest innovations we're planning to introduce as of next year. And we've been working really hard with AWS to listen to all of you and all of our customers that have been asking for an out-of-the-box integration, which is the new AWS Health and ServiceNow integration. This is a paramount step because we are partnering in order to essentially allow you to ingest those events, those lifecycle events, specifically the scheduled changes and the account notifications into the ServiceNow platform directly, automatically, which means for each one of those changes, you'll automatically get the blast radius impact, and you'll be able to see not only for each account, but also how many resources are impacted, how many application services are impacted, and eventually how many business applications are impacted. You'll get all of that, plus proactive notifications to who really needs to take care of those changes. And don't worry if this doesn't look as clear yet, because I'm going to show you a demo. Now, another part that you need to keep in mind is ServiceNow, we've always partnered with customers that are deploying this technology at scale. So you're deploying essentially zero-touch changes at scale. And I'm now going to switch screens so I can show you a demo. So let's imagine that for a moment, we are still in the AWS Health dashboard. Who is familiar with this dashboard, by the way, the AWS Health dashboard? Right. This is just your regular interface where you can clearly see all the upcoming changes, or I would say lifecycle events. You can see all the different categories and information about each one of them. Let's say that we focus on one of the Lambda planned lifecycle events here at the very bottom. Of course, you'll get all the details that Andrew was showing you earlier on the context from an AWS point of view on the ownership of that Lambda function, etc. But let's say that you want to get more. You want to know how many application services are going to be impacted. How is my business potentially being impacted by this upcoming change? And how do you automate your change requests and change tasks so you effectively do not need to manually create them? And that is exactly why we already have, by the way, a product that is very useful for all of your cloud governance use cases, not only the event lifecycle use cases, which is Cloud Workspace. This is a one single pane of glass where you can see everything about your cloud resources, the way that they are divided between on-prem and in the cloud, and also you can see just everything that you need to care about your cloud deployments, such as a clear breakdown of all of your cloud accounts, but not only with the traditional details about costs, about ownership, but multiple levels of ownership, multiple associations to your business, let's say, cost center, or business applications and service mapping, which means you know exactly how each account is related to each other part of your business. Now, let's say that we want to dig deeper, and we are impersonating, in this case, a specific owner of the Center of Excellence, of the Cloud Center of Excellence. Let's say that you want to know a little bit more about everything else that is happening to your specific environments. This integration that we're just announcing will essentially connect to your AWS Health dashboard and essentially capture all the different upcoming notifications and schedule changes and bring them into ServiceNow so you know exactly what's happening to the different cloud environments that you are managing. And you will get also a clear breakdown of how these changes are effectively impacting your different resources. Specifically, you can see here, you'll also see a breakdown of the different resources that are primarily impacted by them. And you can, of course, dig a little bit deeper inside each one of these categories, such as, of course, the Lambda function. And in this case, you'll see that that very same Lambda function planned change or planned lifecycle event is effectively already captured in here. Now, of course, ServiceNow is not only going to have the context that is already coming from AWS. It will offer you more. As a matter of fact, you'll have all the different affected accounts that are being brought to ServiceNow with the ServiceNow context. You'll have ownership of whoever needs to act on this because you already have an automated change request that is being created, is being already created for you. Now, the change request contains all the different details that you need to care about. Specifically, we can see that there is already someone that has been assigned to that change request so that they can act on it. You have a different priority information. You have the service context, so you know exactly which of your services could be impacted by it. And more specifically, all the different details have also been pulled directly from AWS into this change. You'll also see all the different resources impacted by that very same change beyond that Lambda function. As I said, the services that will be impacted by them, and most importantly, you'll have all these different change tasks that will be created for each single account that is impacted by it. So you don't need to do any manual tasks any longer. Everything is already pre-made for you. Now, the cloud leader will want to know how these change tasks are processed, and you'll be able to decide who needs to act on them, who's the owner, but not only a single specific user, but rather also a bigger user group that will be assigned to them. And they will, of course, get all the details that we already talked about, and also about the affected CIs, record history, but more importantly, this is the view that you need to keep in mind. This is where everything that we talked about comes together, where all your technology infrastructure is being connected meaningfully to see how each single component is effectively impacting your services and beyond your business applications, which means you're finally identifying the bridge between your ideal world, where you have your business enterprise architecture designs, and your real as-is IT infrastructure. Now, that was a quick demo for you, but I would kindly ask you, if you are interested to know more and specifically to partner with us to work on these innovations, please do scan this QR code. We're absolutely very happy to collaborate with you, and if you want to stop over just for a few seconds after this presentation, we'll stay here so we can get any of your questions. And that was my part, so I'm going to hand it back over to you folks.
Yeah, thanks everyone. So we are going to take some questions off the stage if any questions, if you have any questions for us. But for 2026, AWS Health's vision is to continue focus on improving or enhancing the ways you can integrate with your tools, bring in some AI features in the next year. But also we have some ready-to-use solutions that, yeah, if you follow this link, it will take you to a place where you can actually access some ready-to-use solutions. So I encourage you to take some time and capture this. But we will also have a booth at the AWS in the Expo, AWS support. I don't see anyone taking any screens anymore, so I'm going to move on to this. So meet us at the AWS support booth at the Expo. Here's how you can find us there, and here's also some other support products, and it can take you to the other features of AWS support. With that, thanks everyone, and I hope you enjoy the rest of re:Invent.
Yeah, thanks.
Awesome.
Everyone.
Thanks all.